Right, hello everyone, and welcome to the lesson, okay? Your first recorded online video lesson with me. I've chosen probability because, to be honest, it's an easy subject to do online, okay? It's actually quite easy, and you can really get into it. And also because probability always comes up in the past paper questions, doesn't it? So there's two major reasons for me going through probability. So the first thing I want you to do is just take a note of what's on the screen. It is a recap of what you should know already. So when you've got any events A and B, this first one here, okay, when you know the probability of one of them happening, the probability that the other one doesn't happen, probability of A dash is 1 minus probability of A, okay. Second, you should know about mutually exclusive events. It means they cannot occur at the same time. Two events that cannot occur at the same time. For example, when you roll a single die, you cannot roll a 2 and a 3 at the same time. It's impossible. They are mutually exclusive. Okay. When you do have two separate events that are mutually exclusive, then the probability of A or B happening is probability of A plus probability of B. Let me take the rolling dice situation. Okay. So probability of rolling a 2, you know, is 1/6. Probability that you roll the number 3 on the dice is also 1/6. What's the probability? You roll either a 2 or a 3. It is, of course, 2/6. You add these two probabilities together. Okay, it's just a demonstration showing you how that works. So the probability of A or B is probability of A plus probability of B. Next, independent events. They are independent if the outcome of one does not affect the outcome of the other, and I'll explain that in context as we're going along. But generally speaking, for independent events, this rule applies. That is, the probability of A and B, them happening at the same time, is the probability of A multiplied by probability of B. So those are the most important probability rules that we'll be using in this unit. Make a note of them, please, or you just print screen that and stick it into your notes. Okay. Next, I want to go through this question with you. Okay, I'll read it out. A bag contains 3 red and 7 blue marbles. John selects a marble from the bag, notes its colour, then replaces it. Mary then does the same. Calculate the following probabilities. Both selected are red. Both selected are the same colour. I'd like to pause the video, please, and have a go at it. And then when you're ready, you can unpause, and I'll go through the solution with you. Okay, so what I'd normally do in class is I'll give you 5 minutes to do it. You see, this would be my starter activity. So hopefully you've had a look at that now. Let's talk you through it. Now, what I'm going to do is I'm going to introduce to you a tree diagram. This section is all about tree diagrams, you see. I'm going to introduce a tree diagram. Let me just start it off for you. Okay, a tree diagram shows you the different outcomes that can happen. So first of all, John selects a marble from the bag. So I'm going to draw the two possibilities of what John could actually select. He could select either a red marble or a blue marble. And I'm recording them like that. And on each branch, I'm going to write down the probability. So for red, it is 3/10 because there's 3 of them out of 10. And for blue, it is 7/10 because there's 7 out of 10 of them. Okay, see how that works? Next, I'm going to extend the tree diagram for what Mary is going to do. So Mary's selection is going to come up next. Now, if John selected a red marble to begin with, then Mary can either select a red or a blue. And the chances of her selecting a red or a blue are what? Precisely, they are the same. 3/10, 7/10. Can you just take a moment to think about why they're the same? Which part of the question tells you that they're the same? Very good. Because this bit here, it says, then replaces it. When John replaces his first choice, then that means Mary has automatically got exactly the same chances of getting a red or a blue the second time. Okay, that's really, really important. The diagram's not complete, so after John chose a blue, potentially, Mary can again choose a red or a blue, and the probabilities are going to be the same. That is the complete tree diagram. Just watch the video again if you are unclear about any of that. Now, before I go ahead and answer these two questions, part A and part B, I'm going to talk a bit about the diagram. What do you notice about each pair of the branches? Pause the video. Good. The probabilities all add up to 1, don't they? If they don't, you got it wrong. The reason they all add up to 1 on each pair of branches is because John can either choose red or blue. There are no other possibilities happening. And then look at the next pair of branches. Mary can either choose red or blue. There's no other possibilities happening, and the same again for the last pair. So just to check you've done this correctly, each pair of branches should add up to 1. Now let's go through the probabilities of what could actually happen after both of their selections. So first of all, John could choose red and then Mary could choose red, and that outcome is denoted like this: 3/10 multiplied by 3/10. Remember the previous slide? Probability of A multiplied by probability of B for when you want probability of A and B. Well, here we want probability of red and red again. The use of the word and is quite deliberate and important. As a hint, when you go along the branches, you multiply the two probabilities together. So 3/10 times 3/10, that is 9/100. Next, what else could happen? Well, John could have chosen a red, followed by Mary choosing a blue. And that probability is calculated as follows: 3/10 multiplied by 7/10. And that answer gives us 21/100. Another possibility, I'm hoping you're working ahead of me, is blue followed by red, which is 7/10 multiplied by 3/10. Of course, it's the same answer, but the order is different, and so it does actually matter which order you're doing it in. And then finally, John could have blue followed by Mary could have blue, and that is 7/10 multiplied by 7/10. And the answer to that is 49/100. Now, can you do something else for me? Have a look at the end results, the final 4 fractions, and just tell me what you notice about all 4 of those. Indeed, they all add up to 1. Why do they all add up to 1? It's because we've exhausted all the possible outcomes that could actually happen. Okay, so this is one of the really nice things about the tree diagram. It makes something that could potentially be rather difficult into something that's actually pretty simple. Well, at least I'm hoping you find it pretty simple. Okay, now let's answer these questions. Part A, probability both selected are red. Well, that's this first answer here, 9/100. So that's done. Part B, both selected are the same colour. Well, either you've got both are red or you've got both are blue. Can you remember what to do when you've got an or situation? Probability of this or this. Very good. You add them together. Probability of A or B, you add them together. So you can see why those rules at the beginning I showed you are really important. So your answer to that one would be 58/100. And you can simplify it if you wish. Okay. Just a little hint on simplifying. When you're doing your tree diagram and your calculations, never ever simplify the fractions. Okay, because what you want to do is frequently you want to add some or all of these end results together, and when you've got different denominators it is a bit harder. So the fact that you've all got the same denominator makes it a bit easier for us to do. Okay, so just a little tip there: when you're doing the tree diagram, the calculations, never ever simplify the fractions, no matter how tempting that might be for you. I'm just going to consider a part C of the question, the probability that each person gets a different colour. Think about that one for me. I'm hoping you arrived with the answer 42/100. Can you see how we got that? You need to add these two together, because what we're looking at is either John gets red and Mary gets blue, or John gets blue followed by Mary gets red. Okay, so the or situation means 21/100 plus 21/100, so 42/100. By all means, you can simplify your final answers, but there's no need. Okay, if the question doesn't say simplify, then my advice is do not bother. Okay, I'm hoping you understood that. If you didn't, please watch the video again.